Hey LunchBox Science! Today we're going to talk about bioluminescence. In other words, living things that glow. If you search for images of bioluminescence, you're going to find some amazing pictures of gorgeous things. Anything from the tiny little firefly squid that's about 3 inches long to what scientists call milky oceans, or entire oceans that glow. So first of all, let's differentiate. Bioluminescence is the result of a chemical process that happens inside the organism's body. It's different from phosphorescence or fluorescence because those processes are a result of the organism absorbing light from its surrounding environment, storing it, and then re-emitting it later. Lazy. So now that we've cleared that up, let's explore bioluminescence a little further. So in order for an organism to bioluminesce, it has to undergo a chemical reaction in its body that always involves a compound called luciferin. That compound is going to react with either an enzyme of some kind or a photoprotein. It depends on the organism. Interesting side note, luciferin, you know, the compound we were just talking about, kind of sounds an awful lot like Lucifer, you know, the devil, which I think is a really interesting connection, and I've always thought that a really cool project would be to explore the origins of scientific names and see why some things are named what they're named. If anybody wants me to write about it and wants to hire me to do it, let me know. So anyway, most animals synthesize their own luciferin, though some animals can kind of cheat a little bit and borrow their bioluminescence from animals that they either ingest or have a symbiotic relationship with, like they let the bioluminescent organism live inside of their body cavity. Most bioluminescence occurs in the ocean, especially at the very bottom of the ocean in what's called the benthic zone. There isn't much, if any, natural light down there, so organisms usually have to produce their own. Most of the glow show that occurs on land is either in insects like fireflies or fungi. Organisms can glow in different colors. You can bioluminesce in the yellow spectrum. Most bioluminescence occurs in the green-blue spectrum, but animals produce different colors by combining their luciferin with a different kind of enzyme. So, what's the point? There's so many cool animals out there that bioluminesce that scientists don't know the answer to that question for every single one of them. But there are some major trends. For example, animals that tend to get eaten by bigger animals like to use their bioluminescence to warn predators that either they're poisonous or just to throw them off. If I was gonna eat something and suddenly it flashed neon yellow, I would be a little put off, I'm not gonna lie. Some organisms, like the firefly, use a flashing neon glowing color to attract a mate. And there's been some really awesome co-evolution happening with bioluminescence. Some predators use it to their advantage. For example, the loosejaw fish, which exists in the very dark depths of the ocean, uses its bioluminescence in a field of light that nobody else can see. So it can see its prey, but its prey can't see it coming. Another awesome example, sperm whales like to follow clouds of glowing plankton. The plankton glow, scientists think, to communicate to each other that there's a threat present, aka the fish, and whenever the plankton glow, the sperm whale knows that fish are coming, and the sperm whales then know that their actual prey, the fish, are there and ready to be eaten. Can we just take a second to appreciate the fact that plankton can communicate via light? What? So even though bioluminescence occurs mostly in microscopic organisms and mostly at the bottom of the ocean, it can have some really cool implications for humans as well. We use a lot of bioluminescence and fluorescent tags in genomic research. We can put them on genes or other microscopic molecules. Once they're tagged with that glowy molecule, we can follow them around wherever they go. In more far-reaching, maybe a little more distant thinking, bioluminescence could eventually help us become less dependent on electricity if we come up with a really neat way to use it to provide light for us. I hope you learned something fun. Thanks for watching, guys. Like and follow on Facebook and Twitter to keep up with all the updates. I hope you're having a great spring, and don't forget to pack your lunchbox.